Hello everyone. So now in this final part of data analytics, we'll see these two terminologies which are very commonly used across the warehousing and the analysis domain. This OLTP and OLAP, where this OLTP stands for online transaction processing and OLAP stands for online analytical processing. OLTP is a terminology that we use frequently to represent our current operational databases, and OLAP is something that we use to represent our data warehouses or data marts. So in your business environment, any analysis or analytics which is done is always done on some data mart or data warehouse, which are the OLAP repositories of the data, and the your current transactional data is stored in an environment which is called as OLTP. So again, to quickly understand, this OLTP is to represent your current operational data, transactional data, and OLAP is your historical data. So on your current transactional data, it seems you can perform almost any kind of data manipulation operation, but on historical data, that is your OLAP data, which is your archive data, you use that data only for read-only purpose and use the data for some analysis or analytics that you want to run on it. So in this session, you'll learn about OLTP characteristics. We'll see what is the difference between OLTP and OLAP. We'll see how data is stored, what are the different database management systems, what is database schema and database types, what is data warehouse, what is subject orientation, non-volatility and time variant factor of the data, what is multidimensional data, what is architectural components of MDM and information architecture. So here in this slide we have certain characteristics which are given for OLTP, and we have some characteristics given for OLAP which makes it unique. So in OLTP characteristics we have different characteristics like the source of the data, and so we have the characteristics and what it means. So we have the source of data, which is nothing but your operational data. So OLTPs are the original source of the data. These are the data repositories where data first comes and gets recorded. What is the purpose of the data? To control and run fundamental business tasks. So every day when you perform your ad hoc transactions or day-to-day transactions, and when certain transactions needs to be recorded or some data generated needs to be recorded, it is the OLTP source which comes first and help you storing the data that later becomes the OLAP when it is archived in some other repository. So the purpose of data is to control and run fundamental business tasks. The nature of the data is to reveal a snapshot of ongoing business process or processes. In terms of inserts and updates, this data is short and fastly inserted, and updates initiated by the end users. In terms of queries, this is relatively standardized and simple queries returning relatively few records. In terms of processing speed, this is typically very fast because this is your current transactional data and the volume of this data will not be as large as your OLAP data or the warehouse data. So in terms of processing speed, this is typically very fast. In terms of space requirements, this can be relatively small if historical data is archived. In terms of database design, this is highly normalized with many tables. So whenever you create databases in any RDBMS, we have a process called as normalization, and we have various phases of normalization, we call them as normal forms. So all these normal forms, and this task of normalization was introduced by a scientist, Dr. E.F. Code, who introduced these rules that will help you creating a good database design, and you can have entities or tables in your database which will contain only the relevant data which will make sense when it is used in some business operation or transaction. So he defined several normal forms, several rules for this normalization, which helps you refining and filtering the data and getting the better view of the data and getting only relevant data within a particular entity or a table. So in case of database design, this OLTP data is highly normalized, and this will have many tables because every table will have only its relevant data, unlike your warehouses where you will see multiple entity data existing in one table or one entity. In terms of backup and recovery, this backup religiously. Operational data is critical to run the business. Data loss is likely to entail significant monetary loss and legal liability. So there are multiple sources where we back up this data. So in case of the server failure or data crash, we are able to retain or get this data from the other places simultaneously, the places where we recorded this data when it was recorded in the primary source. So this data is very crucial because this is something which requires to complete your ongoing processes within an organization, and this is the data which will be required by every now and then by the end users and the information consumers. Then we have certain similar characteristics of OLAP sources. So database is the best example of OLTP, and data mart or data warehouse, which are historical repositories of your data, are best example of OLAP. So again we'll see the characteristics and what they mean with respect to OLAP. So when I say source of data, this is consolidated data. OLAP data comes from the various OLTP databases. So after some time, some interval, when your OLTP data sources, the size of the OLTP data sources become large, we archive certain data which is not required in our daily operations or transactions, and we put it in another repository which we start calling it as OLAP. So this is some consolidated data, some archived data, backed up data, and OLAP data is always created using the OLTP databases. The purpose of this data is to help with planning, problem solving, and decision support. Only using this data you will be able to answer some questions like, so we can have a product table which is giving the current perspective of the products that your organization has. For example, let's say there are several attributes or variables which are describing a product. So you have something called as product ID, you have product name, you have a description of the product, you have price of the product and the quantity of the product. So there are various fields or attributes or variables which are describing this product table, and let's say in your product table you have only the current prices of those products. So it is not stored in this current OLTP database what was the price of this product last year or last year or 2 years back or 3 years back. In case if someone asks you a question like, by what percentage the price of this particular product has increased compared to the last year, you'll be able to answer such questions only if you have this data stored in some historical data repositories. So there comes the role of the data warehouse. Data warehouses or data marts have all your data stored, all your previous data stored. So right from the launch of the product till the current price of the product, okay, you'll be able to get the price of every year for that particular product, or every price change information you'll have in those repositories recorded, which will help you answering such questions if you're there to answer a question by what amount or by what percentage the price increased. So that's the reason why this historical data repositories like data marts and warehouses are very crucial. So purpose of the data is to help with planning, problem solving, and decision support. The nature of the data is multidimensional views of various kinds of business activities. So unlike your OLTP data, which is most of the time two-dimensional data where data is stored in rows and columns, and you'll not be able to perform operations like drill down or roll up or expand or collapse. In warehouses, you'll be able to perform those operations of drill down, roll up, which are your expand and collapse operations, and operations like the slicing and dicing. Okay, so you can create any particular view of the data that your business consumer or the business user needs, which is at times difficult when you are operating on the OLTP data. Inserts and updates. So there are periodic long running batch jobs which refreshes the data. So you can set some frequency for the data archival or the backup operation that you have set, and that's how the data gets inserted in your data repository, that is your OLAP or the warehouse or the data mart that you have. In terms of queries, it's mostly the select queries or the queries that fetch you data and you can read the data and use the data for some analysis performed on the OLAP sources. So these there are often complex queries performed on OLAP data sources, which involves lots of aggregations. In terms of processing speed, this depends on the amount of data involved. Batch data refreshes and complex queries may take many hours, and query speed can be improved by creating indexes. So we have this feature of the database is called as indexing, which helps you quickly locating a piece of information from a huge chunk of data that you have. In terms of space requirements, the size of the warehouse or the OLAP will be much more than size of the OLTP system, because OLTP has only your current operational data and the OLAP has stored your historical data. So definitely the size of the warehouse or the OLAP would be more or bigger than the size of the OLTP system. In terms of database design, this is typically denormalized data with fewer tables, and this uses star or the snowflake schema. So as we discussed sometimes back, there are ways and means by which you can arrange this dimension and fact tables of your warehouses or the OLAP system, okay, called as star and the snowflake schema. And typically these schemas will have tables in denormalized form, because in normalized form you will have many tables and it will be difficult to manage too many tables in a huge data repository. It's easy to manage them in OLTP system in your current operational database, but not in the data warehouses. So most of the time we remove the normalization characteristic or feature from our data while transferring the data in the warehouses or while creating this OLAP type of the data. In terms of backup and recovery, instead of regular backup, some environments may consider simply reloading the OLTP data as a recovery method. So as we discussed earlier, we can set frequencies when you want to back up this OLTP data and write it to your OLAP system. So it can be weekly activity, or it can be monthly activity, or you can perform this at the end of every quarter. So that frequency can be set, and the data writing operation in your OLAP system can be automated that way. So to quickly summarize OLTP and OLAP and see the differences between the two. OLTP is transaction processing, whereas OLAP is analytical query processing. OLTP is time sensitive, whereas OLAP is history oriented. OLTP is operator view, whereas OLAP is managerial view. OLTP is organized by transactions, for example order, input and inventory, whereas OLAP is organized by subject. It could be customer or product. So as we said, the OLTP follows the normalization rules and OLAP follows the denormalization rules. OLTP is a relatively smaller database as compared to the OLAP, which is large database size. OLTP can be used by many concurrent users, whereas OLAP is relatively used by few concurrent users. OLTP is your volatile data, whereas OLAP is your non-volatile data. OLTP stores all the data, whereas OLAP stores only the relevant data. OLTP is not flexible, whereas OLAP is the flexible view of the data. So there you can perform the slicing, dicing, roll up, drill down like operations. Now let's understand how data is stored in databases and database management systems. So database is nothing but collection of relevant data. It is persistent, logically coherent collection of inherently meaningful data relevant to some aspects of the real world. A database management system is a collection of programs that enable users to create and maintain a database. A relational database management system is a database that treats all of its data as a collection of relations. So when I say a database management system, a DBMS, a few years back we had a tool called as FoxPro, which was the best example of database management system, which used to allow data in the form of tables as well as in the form of flat file. Now the current database management systems that we have, which are called as RDBMS, like Oracle, Sybase, DB2, MySQL, MS SQL, all these are RDBMSs which strictly requires the data to be in the tabular form. So when we talk in terms of DBMS, we had this FoxPro, which was allowing data in the form of flat files, in the form of relational tables. But we have this RDBMSs which always requires the data, strictly in the form of relation, which is called as a table. So every piece of information in RDBMS has to exist in the form of table. Okay, that's how the RDBMS is different than your database management system. So both these contributes to your OLTP and the OLAP data. If you want to understand the architecture of database management system, this is how it will look like. So you have this different views of the data, external views of the data, which is representing the external layer of this DBMS, and then you have this conceptual level, which is your enterprise wide view of the data, and then you have this internal level, which is the storage view of your data, and then you have the storage level, which is giving you the physical view of the data, that is your physical databases. Okay, in terms of the schema for this database, whenever within this RDBMSs you create these databases, there is a schema owner for the database. So by default it is the database owner who is the schema owner. So I mean, within these databases you can create different objects. So we can create so database is not just collection of tables, but there are other database objects too. Like we have something called as indexes, which are used to perform which are used to improve the query speed, and they help your queries perform the search operation better and faster. Then we have this procedures, which are basically collection of multiple queries that you have written inside one particular unit, and that unit can be executed as and when needed. Then we have this views, which are called as virtual tables. So this views basically helps you providing security to your base table and giving only the desired view of the data to the end user. And then we have this various constraints where you can enforce some data validation rules on your table by creating a primary key. So if you make some field or some column as primary key, then the end users cannot duplicate that particular field. Then we have this not null constraint, which forces the user to supply a value for a given field. Then we have this foreign key constraint, which helps you relating to entities in one particular schema or database. Then we have this check constraint, where before you write that input in your OLTP system, you can check if that input is as per your business rule or not. Then we have this default constraint, which is used to handle this default this missing value problem. So wherever user does not enter field in your does not enter values in your field, you can, instead of having a null value inserted there, you can have some default value inserted. So we have lots of database constraints available in OLTP system that we can enforce, we can implement, and ensure that the data comes in the right format. So all these contributes to your schema, and they make the various objects of the schema. Then we have various database types. So just now we discussed the relational database concepts. Apart from relational, we have something called as flat file data, which is existing in non-structured or unstructured format, in flat file format. Then we have this hierarchical view of the data, where you'll see different entities that will appear in a hierarchy, and there'll be a flow or path to reach those entities. And then we have this network, which is unlike hierarchical, which is always top to bottom. This network will be top to bottom and bottom to top, where you can apply the drill down and roll up like approaches. Then we have this relational, where every piece of information is stored in the form of table. And then we have this object oriented, which is used by most of the object oriented programming concepts. And then we have this combination of object and relational, which creates this object relational schema that gives you the power of the relational databases as well as the object oriented based databases. So according to this person, Bill Inman, who defined what is a warehouse, a data warehouse is a subject oriented, integrated, non-volatile, time variant collection of data in support of management's decision. So there are many definitions of warehouse. This is one of those many definitions, where as you see these highlighted terms, so these are the characteristics of warehouse. It is subject oriented, meaning it will have information of domains or entities rather than specific information about every sub entity that you have in your data repository. It is an integrated data, it is non-volatile data, it is historical and permanent data, and this is data which is captured at different time intervals. So these contributes to the definition or features of a data warehouse. So this is subject orientation of a data warehouse. As you see, you have this operational data which was collected through various sources like this leads and prospects and quotes and the orders databases. And then you have this data warehouse, which can be represented as customers and products and reasons. So as you see, this is subject oriented rather than entity specific, as you see this definition. So if you see the left hand side box, that represents your OLTP view of the data, and if you see the right hand side box, that represents the OLAP aspect of the data, where the data is more subjective rather than entity based. This is the non-volatility nature of the data warehouse, where you can on the current transactional data, the OLTP data, you will be able to perform almost all these transactions like insert and change and replace and delete. Whereas in case of the OLAP data, the data warehouse data, you will be able to perform only the data load operations, and you will be able to write queries that will help you fetching the data and use the data for further analysis or reporting. So this is the time variant factor of the data warehouse, where you see the current value data. For example, time horizon 60 to 90 days. Key may not have element of time, whereas this data warehouse, which is giving you the data in the form of snapshot, this time horizon is 5 to 10 years. As you see, the time range here in warehouses much larger than the time, a fraction of the time value that you have in operational data sources. Key has an element of time. Data warehouse stores historical data most of the time, unlike your operational data sources, which contains the current data. So this is the multi-dimensional view of the data, where data is interpreted as measurement along multiple dimensions. The multi-dimensional data model is designed to solve complex queries in real time. This is a central measurement. A central measurement is chosen, such as value of cells, and projected along all possible dimensions. And this multi-dimensional data model is integral part of a lab system. So these are the architectural components of MDM. You have this technology to profile, consolidate and synchronize the master data across enterprise. And you have applications to manage, cleanse and enrich the structured and unstructured master data that you get in your environment. So this is the information architecture in the form of data gathering, that is data generation, and how this data is recorded in business applications, and then how enterprise application integration is done on this individual data sources, and then how it is transferred to the master data management, and how this enterprise data warehouses are formed by applying ETL, and then this data is given to the information consumers for further analysis or to make some strategic decision. So there are some key questions for the master data management design. For example, who are the business clients? What are their business objectives? What business processes are performed to achieve those business objectives? What data is necessary to perform the business processes? Is the absence of high quality unified view of that data impeding business success? And if so, where are the quality, consistency, completeness and synchronization characteristics that will close and perceive the gap? So these are the MDM domains: the product master data, the material master data, the customer master data, supplier, contract, financial master data and employee master data. So with this, now I hope you all have some idea on what is EDA, what is MDM and what is warehousing, and along with warehousing, now you also know what are the current transactional databases. I mean, what is OLTP and what is OLAP and what is the difference between the two. So hope this knowledge will help you interpreting the subsequent topics that you have after this easily, and we'll explore more, or we'll see some more characteristics and implementation on these topics in our upcoming modules. Thank you very much.